And the bus is gone. Get a pen you can rely on? Big Crystal, the long-lasting pen with perfect ink flow.
Wamune.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamune.
Kids Kingdom Kindergarten and Daycare. Somero ly'abaana bato omuzadde leeta omwana ogenda okola ebibyo ebyokuzanyisa by'abaana byonna mu nsi tubirina ate ng'abaana we bazanyira wagazi nnyo. Jjukira security enka amasomero gonna gali mu kikomera abasomesa be tulina bakugu mu baana abaana tubaliisa bulungi nnyo munnange. Tulina main campus e Buddo Naggalabi nga bwakayisa Buddo Junior.
Yeah, good afternoon to you, my dear students. I want to welcome you to this week once again. The teacher is Teacher Kakuru, DR. The subject is mathematics. We are attempting to make a final wind-up on continuous random variables, looking specifically at PDFs. But today, as we started in our last lesson, we had made an introduction on cumulative distribution function. So we shall be looking at cumulative distribution function, and if time allows, we shall wind up with a uniform distribution. I would like to interest you to always follow up Teacher Kakuru. Teacher is T-I-C-H-A, Kakuru, D-R. Even beyond this lesson, the Teacher Kakuru has a YouTube account where you can follow. He also has a Facebook study channel called Let's Learn from Home. I want to interest you, dear students, parents, go to those pages, subscribe, share, and like so that we can continue learning even out of the studio. I left you with a number which I want to put over here, and then we shall be started. That a continuous random variable, x, has a probability density function given by f of x equivalent to x out of 8. The range is 0 to 4. Elsewhere. And they are telling us, one, to determine the cumulative distribution function. This comparatively with the PDF is written with a capital F and a capital X, and therefore it is a cumulative as said. And then they also want us to sketch this function. We said there are three important properties which for purposes of this lesson I should be able to include. That one, the cumulative distribution function as expressed as a function of infinity should always be equal to 0. And we defined infinity as that lower limit, in this case 0. 2, we said that the cumulative distribution function of positive infinity will be equivalent to 1. And positive infinity here is defined as the upper limit of the given PDF function. And lastly, we said that the function f of x, which is cumulative, is an increasing function. Is an increasing function. It is an increasing function. Therefore, with these three in your mind, it implies that we need to look at the probability also of x less than small x will be considered as the integral from infinity to t. We can take it to x of f of t dt. Yeah, different books could look at these alternately, that we can work with x and end with t as we generate our distribution function. So I want us to move straight to the solution, and any other conditions we shall add them as the lesson progresses. So to convert or to find this cumulative function of a PDF, for this particular case, x out of 8, we shall consider that for x less than 0, for x less than 0, that is referring to the infinity, our f of x should be equal to 0. Our f of x, that is negative infinity, should be equal to 0. This implies that if we look at the question at hand, we are saying that f of 0 here is 0, since the lower limit is 0. Since the lower limit is 0. Now, for the function now looking at the range, for the range 0 to x to 4, this is where the function of our interest is. For the range 0 to x to 4, we will look at the function, the cumulative function we want, f of t, should be equivalent. We substitute x for t to t out of 4 for that range. And here, if we are looking at the cumulative function, the inequality signs must all be considered to be less or equal to, less or equal to. So we are going to integrate. We are going to integrate to find now our f. Our f of x, which is our interest, will now be the same as f of 0 plus the integral from, in this case, 0 to x of t out of 4 dt. We integrate this expression in addition to our first value here, and what we get will, of course, be our cumulative function. So our f of x will definitely be equal to 0, because here we have the minimum limit of the cumulative function according to our range is 0, plus we integrate from 0 to x t out of 4 dt. Now when we integrate here, we already looked at integration. We have been dealing with integration all through. Our f of x will therefore become, I will now eliminate the 0, because the 0 is not going to have a positive impact here, and integrate this to get my t squared out of 4 times a half, but my limits are 0 to x. This implies that my distribution function that is cumulative upon substitution of the limit will be x squared out of 8. Will be x squared out of if I put in my expression, this is t squared over 4 times 1 over 2. My function was x out of 8, sorry. So this should be out of 8, out of 8, out of 8. So it will be out of 8, which will give me 16. So we can now conclude, this is the cumulative function we want, but we can now conclude and and put in the other condition here. We start with this. We check. If we put in the upper limit here of x and we don't get a 1, it means that our cumulative function is not correct. So, for x as 4, our f of 4 is expected to give us 1. That will be 4 squared out of 16, and this will indeed give us 1. Once we satisfy that, then we can say that the cumulative function that we are looking for, f of x, is going to be equal to 0 for x less or equal to 0. It is going to be equal to x squared out of 16 for the range 0 less or equal to x less or equal to 4 is going to be equal to 1. Now the 1 is going to be our else. We won't be able to have our elsewhere. This is for x greater or equal to 4. Here, if we put in our x greater or equal to 4, we get that, and this will give us our cumulative function, or cumulative distribution function will be given by that. Important steps as you prepare to copy. Look at the lower limit. If you feed in the lower limit, you must get a 0, and if you feed in the upper limit, you must get a 1. And the function is supposed to be increasing, and then the probability that x is less or equal to another smaller value is equivalent to the integral from the lower limit to the upper limit of f of the dummy that we call dt. We can capture this solution, my dear students, as we wait shortly after 2 minutes to look at the sketch. But as you capture the solution, I want to remind you that the sketching is not any different from the sketching of a PDF graph or curve. Indeed, as you copy the solution, I want to emphasize that when it comes to sketching, we shall mainly focus on this function. We shall mainly focus on this function, and we shall still use these two limits. And as we use the two limits, remember, since the function is already squared, it suggests it's not a straight line. And we said if it's not a straight line, we will have to choose the lower value, the upper value, but choose another value in between, and then we can sketch our curve. Yes, I expect that the candidates are capturing this. There are quite a number of questions we are going to answer with this number. The first one being determining the f of x, which we have finished. The next one being the sketch, which we are yet to move to. My dear candidates, I assume that we should be moving to the next part, and I am going to start from here, and we try to sketch. Let us call that part 2. To sketch our cumulative function, we said simply consider the limit. For 0 less than x less than 4, we are going to have our x, and this time our f of x. And we shall use 0 and choose any other value between 0 and 4. Preferably, we can choose to use 3. So if our f of x, which is now x squared out of 16, that is the lead function we shall pick. With x as 0, we shall get 0. With x as 3, we shall get 9 out of 16. And with x as 4, we shall get 1. And once we finish getting that table, I want to assume that the candidates have already finished capturing that part. Like I told you, technically, any student must be technically upright, even in a classroom setting. I told you, should you come in late and you are lucky that the teacher allows you in the lesson, in a normal school setting, do not start where the teacher started. Start where you found the teacher. But that is only possible in school because you have colleagues that will give you the notes that, or the part that was handled before the teacher, before you came in. Here, if you have not finished the part, I always advise that simply take a snapshot of what appears here on from your TV screen, and we proceed. Now, to sketch our function, I told you already have the experience. I'm only guiding you in our sketch. We have got 0, which we know very well is here if this is my origin. I'm going to use 3 and 4. This is our x. So if I assume my 3 is here and my 4 is here and my 0 is of course also there, my 9 out of 16, I can let it be here, and my 1, I can let it be over there. So 3, 9 out of 16, we can plot it to be over there, and then 4, 1. 4, 1 can be over here. As you can see here, my distribution function has 3 parts. It has the part where f of x is 0, f of x is this, and f of x is 1. So at this point, I have my f of x as 0, as you're aware we must label. From here, between 1 and 3, 0 and 3, I will connect this, and then I will connect that. So between 0 and 3, the whole of this is my f of x being equal to my x squared out of 16. And beyond 4, that's why we said for x greater or equal to 4. It means from here onwards, my f of x is equal to 1. If you have successfully done that, then we can say that you have sketched your cumulative distribution function. You will have sketched your cumulative distribution function. That was part A. The question is ongoing. Remember, I left this question last time, and it is a very good example to start with. They want us to find the probability for part B that 0.3 is less or equal to x less or equal to 1.8. There is a condition here. There is a condition here, but I want to give a minute for you to capture the sketching bit. Generating the table for the points to sketch. Of course, the points are 0, 0. You must capture them, 9, 16. But because we have done this before, I don't expect students to have challenges with the sketch bit. For the cumulative distribution function here, I had mentioned this. Students should note that the P of A less than X less than B, just like we saw at the start of this topic, is equal to the P of A less or equal to X less than B. will also be equal to the P of A less than X less or equal to B, and will also be equal to the P of A less than X less or equal to B, and will be equivalent to the cumulative function of B minus the cumulative function of A. This is very important. This is very important, and it is going to help us to simply do that number. So what do you need to know? You simply need to know this expression. Once you know that for a cumulative distribution function, the probability of any two given limits is the same as the subtraction of the upper range given minus the lower range given substituted in the cumulative function, then we can say that P of 0.3 less than X less than 1.8 is going to be the same as F of 1.8 minus F of 0.3. But remember that our F of X is X squared out of 16. Therefore, it implies that our probability will be 1.8 squared out of 16 minus 0.3 squared out of 16. I'm not going to square. I will simply write the next step. And I want to confirm to you students that even in an exam, if you moved from here to the final answer, you will score all the marks in mathematics. So our final answer, therefore, we can say that the probability of 0.3 less or equal to X less or equal to 1.8, when you compute, should be able to give you approximately 0.197. This is 3 significant figures. They may condition you to give your answer to a known number of significant figures. They may condition you to give your answer to a known number of significant figures. We can have another part, part C, to find the median. Find the median. Find the median. Again, I want to mention that this is very important. And there are other conditions that are coming. To find the median, this is also conditioned as the cumulative distribution function of the median, if we let M be the median, is obtained by equating the cumulative distribution function when you substitute in X as M to be equal to a half. When you substitute in X as M and you take that equated to a half, you will be able to get the median if the function is a cumulative distribution. This implies, therefore, that our X squared out of 16 will be able to give us the median if we put in our limits as 0 to M. And this will imply that our M squared out of 16 will be equal to a half. Therefore, our M squared will be equal to 8, because this will cancel with 8, implying that our M will be the square root of 8, which you can write as 2 root of 2, or which you can write as 2 times 1.414, which will give you approximately around 2.83 to 2 dPs. That will be the median. So important facts to note for the median. You should note that when you substitute the median in the expression for f of x, it should be able to, the m will substitute where the x is, and you will simply solve that to obtain the median. You will simply solve that to obtain the median. I told you it is a main question because it exposes a student that is attending this lesson to a number of skills. And the last part, but not the least, that I'm going to call part D is to find the interquartile range. Interquartile range. To find the interquartile range. As you capture those values, I want also to summarize here the conditions required. We have what we call the lower quartile and the upper quartile. The lower quartile is a quarter. Lower quartile for a cumulative distribution function is equal to a quarter, and we are supposed to equate our expression to a quarter. That means that f, the cumulative distribution function of what I will call the lower quartile or quartile 1, is equal to a quarter. The upper quartile, which we shall call 3 quarters, it's just a language mindset that students should note. This is 3 quarters, and therefore in our distribution function we call it Q3, and we equate it 3 quarters. Just like we are using FM, we shall simply substitute in our distribution function, we substitute Q1, we get the value, we equate it to a quarter, and we look for our value of x. And similarly, now if we subtract that difference between these two, is what we call the interquartile range. The interquartile range, before we work it out, is therefore equivalent to Q3 minus Q1, which is important. And we have the semi-interquartile range. Semi-interquartile range will be, semi means a half, into this difference, into Q3 minus Q1. Students following this lesson, specifically S5 and S6 students offering principal mathematics, take note of this. And now I can comfortably move to solve that number over there. I am not going to talk about the percentile now, because I will not consider it for this particular question. So I can say that since our f of x is x squared out of 16, our FQ1, which is equal to a quarter, will be the same as Q1 squared out of 16 is equal to a quarter. And this implies that my Q1, from here, my Q1 is going to be equal to my Q squared. Q1 squared is going to be equal to 4, and therefore my Q1 is plus or minus 2. Similarly, f of Q3 will be equal to 3 quarters, and this implies that Q3 squared is equal to Q3 squared out of 16 is equal to 3 quarters. So if we feed in, or if we simplify that, we shall be able to get our Q3 squared as 3 times 12. 3 times 4, which is 12. Okay, times 16 out of 4, which I can say is 12. And therefore, Q3 will be equal to the square root of 12, which I can write as this, and simplify to 2 root of 3. 2 root of 3. So we have, of course, this is plus or minus, as I usually say. We have this part and this part that we should subtract to give us the interquartile. To give us the interquartile. When you subtract, we can therefore say that Q3 minus Q1 will be, if we subtract the 2 directly, we should be able to get approximately 1.5 to 2 significant figures. If we round it off, we should be able to get that as our answer. And like I said, if they wanted the semi-interquartile range, we would simply divide that by 2. Would simply divide that by 2. As you capture that, we can confidently move on to another number, and when I write EER, I mean exercise. This number here that I'm going to put, I will encourage you to try it out. I would encourage you to try it out. That a continuous random variable, x, has a PDF given by f of x. I told you the difference between a PDF and a cumulative distribution function. There are many differences, but they are related. That if we want to move back from the PDF, from the cumulative distribution function to the PDF, we differentiate. So the exercise I want my dear students to try out, of course, we always say in your free time, or where the free time in this case means after this lesson, is this one. And here, they want you to simply determine f of x and sketch. You are under personal liberty to try out all the parts that I have indicated in our first example up to the last one. But my question will stop here, but you can subject that number to all the other parts. Meanwhile, I want us to look at another example, which I will call example 2. I have always shared with my students that the reason why we do various examples is because each example has a different technique that we want to share. Look at this next example. This example has 2 functions. It is a PDF that has 2 functions. In one, And of course, it ends with 0 otherwise or elsewhere. I expect that we should be done with this area. The question is over there. What do they want us to find? Definitely, they want us to find the cumulative distribution function and sketch it. Part 2, that is different from the first part, they want us to find the probability that x is less than 1. Part 3, they want us to find the probability that x is greater or equal to 2. And part 4, they want us to find the probability that negative 1/2 is less or equal to x and less or equal to 2.5. So as we proceed, I expect that, my dear students, you already remember how we got our cumulative function for the first case, which I can actually now, no, this is a trial number which I should leave. I will be rubbing off when I finish utilizing the available space. We said we look at for part 1, we consider that for f of x, for x less than the lower limit, less than -2, the f of x must be 0. Must be 0. And that implies that our f of that value is equal to 0. So since we have two functions, we shall apply the same for this one. The upper limit here is 0. So for us to get the function for f of 2, we shall get the cumulative function for x will be equal to f of -2 plus the integral. This x will be changed to our dummy, which we are using as t. So you shall integrate 1/2 into t plus 2 dt from infinity, which is now going to be our -2 to x. It is from here to this limit, from this to this. Then when we finish getting a cumulative function, we will feed in the upper limit. And it should be able to give us, in this case, it will not give us 1 because we have not finished the whole function. We shall just be getting that part. So if we feed in our next step, our f of x here will definitely be 0 plus. I will integrate this straight away, and it will give me 1/2. This will give me t squared over 2 plus 2t. Remember, this is subjected to 1/2 -2x. The 1/2 is a multiplier of the whole bracket. So my f of x here will be, I will eliminate my 0 and feed in my x, and it will give me 1/2 into x squared out of 2 plus 2x. That is x minus, when you feed in the 2, minus 2 squared out of 2 plus 2 times minus 2. I'll make these square brackets. And I hope you will be able to see that when you simplify this, my dear students, you should be able to get this was a half. You should be able to get, I am going to adjust this. I think I changed this to 2. It should be 5, since we have not entered it in to stay the same. 1 out of 5, 1 out of 5, and 1 out of 5, and 1. Yeah, this stays. So my f of x for the first part will simplify to 1 out of 5. When you simplify everything in bracket there, you should be able to get x squared out of 2 plus 2x minus 4. When you simplify that, it should be able to give you that, which we can reconcile to get f of x as we are taking a common LCM. X squared, if we take the common LCM as 10, we shall get plus. I'm taking the common LCM here. I want it to be 10. So I'm entering this. This is x squared out of 10 plus 2, 5. That would be 10x. By 1 to be 10, 20. 20x. By 1, if I enter in my 5, if I enter in my 5, I'll have x squared plus 4. Because if it is 10, this will be 4x, and this will be times 2, which will be 8. This simplifies to 2, not. So this should simplify to 2. And therefore, this will be plus 4. This will be our f of x. But that is only dealing with the first part. So if we look at the next part, here we put in our f of the upper limit of 0. If you put it in here, it will be 0 plus 4 out of 10. And our f of 0 here will give us 2 out of 5. So we apply the same here. That f of x will be, we use the 2 out of 5 and we add on the integral from 0 to x. From 0 to x of the next term, which is 2 out of 15 into 3 minus x. Now this should be t dt. And again, the final expression here will give you 2 out of 5 plus, if you integrate this, you'll have 3t minus t squared out of 2. The limits are 0 to x, but we have our 2 out of 15 here as a common factor. So when we substitute in these limits, I will give the final expression here. After substituting in, that should be able to give you 6 plus 6x minus x squared out of 15. Out of 15. Now to get the final, or to check whether that is the final expression, we put in our final limit. If x is 3, then it implies that our f of 3 should be able to give us 6 plus 6 times 3 minus 3 squared over 15. And when we compute this, this is 18. 23 minus 8 out of 15 ideally it should be able to give you 1 if the expression you get is correct. And therefore, we can conclude and say that our function f of x will be, we started here, will be 0 for x less than or equal to -2, which was the lowest. Then it will be 2 out of 5, which we got after feeding in. That is for 0 less than x less than for the next range, -2 less than x less than 0. And then the next function, the function we have for the next part should be this one. This should be the one for the second range. X squared plus 4x minus 4 over 10. And then the last function here is 6 plus 6x minus x squared over 10. And this is for our last range, 0 less or equal to x less or equal to 3. And we must always end with a 1. The 1 is for x greater than the upper limit, greater or equal to 3. This gives us our final function f of x. That gives us our final function. When there are two functions originally given, that will be it. As you may be aware, I want to tell you that these concepts, for you to pick them very well, we don't need to rush you. As mathematics teachers, we don't need to rush you. So I will skip the sketch, assuming that you can be able to understand it. I'll simply get the table and we proceed. X, f of x, because they are now two categories, but we consider the sketch for both of them by looking at either of the two cases. Now, since our limits are between -2 and 3, we shall use 0 to 3. We shall mainly focus on this, but we shall also focus on that as well. So if I start with this one, from -2, since it is a curve, we shall include another value, say -1 and 0. We get our f of x. This should be 0, this should be 1 out of 10, and this should be 2 out of 5, which we got there. The coordinates can be picked from there. For the next curve, f of x as this last one, our x and f of x can also be got. And we have 0, 1, and 3. 0, say 1 and 3. And we can get these coordinates. We can get these coordinates as 2 out of 5 because this is shared. And then 11 out of 15 and definitely 1. When you sketch this graph, quickly I could say it will have to start from -2, 0. It will move to our -1 if it is somewhere there, 0. -1 is 1 out of 10, which can be here. And then it will move to 0, 2 out of 5, somewhere here. And then it will move to 1 for 1 and 3, 1 to 11 out of 5, and then 3 somewhere there, 1. So you'll find that you will get a sketch of this nature, and it will move to here. When it reaches here, it will stop rising. You must label this, label that, and label that region as well for the curves. So there are three, as you can see. The region up to 0 here should be labeled with the first function. The region from 0 to 3 here should be labeled with our f of x as 6 plus 6x squared minus x squared over 15, and then should be labeled as f of x equaling to 1. I want to emphasize the next part in the interest of time. If they say px less than 1, this is simply equivalent to the function, and you put in 1. But if you look at the function, 1 is between this second range. So you will use the second function only to get that probability, and therefore px less than 1 will be obtained by substituting 1 here. 6 plus 6 times 1 minus 1 squared out of, this is 15. Out of 15, and when you feed in, you should be able to get your answer as 11 out of 15. P x greater is the same as 1 minus p of x less or equal to 2. If it is greater, you subtract from p of x less than 2, and this you have already got it as 1 minus f of 2, because this is interpreted as f of 2. Upon substitution, if x is less than 2, you come back here. X is less than 2 in this range again. You ignore this one and use that one. And that would definitely give you, if you substitute p of x less than 2, will give you the final answer as 1 out of 15. Last but not least, our p of negative a half less than x less than 2.5 will be equal to f 2.5 minus f of negative a half. And when you substitute in, as I said, this should be able to give you 43 out of 120. In the interest of time, I want to ask you to look for several questions from the question bank book and try out these skills. When we meet next, we shall be able to finalize this topic by looking at the wind-up of this area and uniform distribution numbers. I want to thank you and remind you, keep subscribing to my Let's Learn from Home page and my YouTube page that is called Teacher Kakurudi Wabinomi. I want to thank the management and thank all of you for attending these lessons. God bless you. Gachali Mabaga.
somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab wamu ne.
She gives you her number, but your pen didn't work and the bus is gone. Get a pen you can rely on. Big Crystal, the long-lasting pen with perfect ink flow.
Wamune.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamune.
Kids Kingdom Kindergarten and Daycare. Somero ly'abaana bato. Omuzadde leeta omwana ogenda okola ebibyo. Ebyokuzanyisa by'abaana byonna mu nsi tubirina. Ate nga abaana we bazannyira wagazi nnyo. Jjukira security enka. Amasomero gonna gali mu kikomera. Abasomesa be tulina bakugu mu baana. Abaana tubaliisa bulungi nnyo munnange. Tulina main campus e Buddo Naggalabi nga bwakayisa Buddo Junior.
Tujjukira ebiseera bye wagendanga mu salooni ew'omuyooyoosi wo n'akuyooyoota n'ovaawo ng'omatidde ng'olabika bulungi ng'era oli mugumu nti buli w'ogenda okuyita kebeera embaga oba kasiki ka mukwano gwo mu buli ngeri abantu bajja kukyuka emitwe nga bakulabyeko. Essanyu lyaffe liva mu kuyambako okutuukiriza ebiruubirirwa byo eri endabikayo. Naye mu kaseera kano nga tulwanyisa COVID-19 obulamu bwo n'okwekuumaako bya mugaso nnyo gye tuli. Y'ensonga lwaki tukkubiriza okwekuuma ng'okozesa Movit Hand Wash, Movit Herbal Soap ne Movit Body Milk Soap. Okumala waakiri ekitone nnyo obutikitiki nga 20. Era tuli bagumu tisinga onoobikozesa kijja kuyamba okwewala obulwadde bwa COVID-19. Tusigale nga tuli batebenkevu era tunyumirwa akaseera ketumala ne famire zaffe. Tuli bagumu nti ng'eggwanga tugenda kuvvuunuka coronavirus.
Move it. All day confidence.